All right, guys, we're going to continue graphing sine and cosine today, but today we're going to include a new vocabulary word or a new shift in the graph, and that is a phase shift. All a phase shift is a horizontal shift in the graph. So our x-axis is going to be affected by everything we do today. You can think of the phase shift as how far the starting point of the cycle is from the y-axis. It is affected by this variable c. You'll notice that it's inside the parentheses. We didn't have that there yesterday. C is the phase shift. It is just the horizontal shift of the curve. Now, something I want you to notice about the phase shift is that it has, in the basic formula, in the parent function formula, it has a minus out in front. So that means that it's going to behave opposite of what we assume it's going to when we move horizontally. So for example, when you take it out of the equation, you're going to take the opposite. So if it says minus c inside, that's actually telling us to go right c units. Versus if it says plus c inside, that's telling us to go left c units. So get in your head that it is opposite of what it seems. I also want you to notice something else. In their parent function, you'll notice that b is on the outside of the parentheses. Remember, b from yesterday affects the period, how long the whole cycle takes to complete. You'll notice that the b is on the outside of the parentheses. Therefore, if x has a coefficient on the inside, we have to factor it out first. We'll go through some examples where we have to do that. And you do that by just dividing everything in the parentheses by whatever b is. And then you would stick it out in front of the parentheses. Remember, the same as before, amplitude you find by looking at a out in front. It's the absolute value of a, and that affects the height of the curve. It's the distance from the center to the top of the curve or from the center to the bottom of the curve, and that affects the y-axis. And then, just like we talked about yesterday, to find the period, you'll do 2 pi divided by b. Again, make sure b is factored out of the parentheses before finding that. Like I mentioned above, the phase shift is just a horizontal shift. It's going to affect where we start on our x-axis. So in other words, the graph will no longer start on the y-axis like it did yesterday. To find the starting point, you're simply going to look at the phase shift, C. That will be your first tick mark along your x-axis. Then you're going to graph a full cycle of the sine or cosine curve. To find where you end on the x-axis, you take your phase shift, C, and you take the length of time that it takes for a whole sine or cosine curve to complete, which is what we call the period. To find the period, remember, it's just 2 pi divided by b, and that will give you your end point on your x-axis. So starting point is whatever your phase shift is, ending point is your phase shift plus your period. That gets you to your end. Now we're going to have a total of 5 tick marks every time to account for the fact that the sine has 5 distinct portions, like center, top, center, bottom, center, or a cosine curve. Starts at the top, goes to the center, goes to the bottom, back to the center, and back to the top. There's 5 different points that we need to graph accurately. So to find what to count your tick marks by, you'll take whatever the period is and chop it into 4 pieces, and that will give you what you count by. We'll practice that in a minute. Let's go on down here, and we're not even going to graph. We're just going to practice finding the new starting and ending points of the period given the equations below. If it helps you, go above each of these equations and label A, B, C, and if there was a D, you could label it as well. Please notice that this B is outside the parentheses, so it's already been factored out, so we don't need to do any additional work here. To find the starting point, you just look for the phase shift, C. Your phase shift is located inside the parentheses. Now remember I said before, when you take it outside of the parentheses, you take the opposite. So it looks like minus pi over 2. That means we're going to start at positive pi over 2. So instead of starting at the y-axis, this graph, we would start at pi over 2. To find the end, we have to take c and add the period to it. Well, we have to find the period first. So go back up to the top, and to find the period, take 2 pi divided by b. 2 pi divided by 2. It's going to take this graph pi units to complete a whole sine curve. So we take c, our phase shift, pi over 2, add pi, the length of the period. 1/2 plus 1 whole gives us 3/2. We keep that as an improper fraction. If you wanted to do that in your calculator, just add the coefficients. 1/2 plus 1 whole gives us 3/2. You can do that in your calculator. You don't have to put pi in the calculator. So this would be our start. This would be our end. Now, one thing I want you to notice is that the distance between pi over 2 and 3 pi over 2 is 1 whole pi, which is just the length of the period. If we were going to graph this now, it would also be helpful. So you'd have a total of 5 tick marks. So you'd have the start, you'd have the end, and you'd have 3 in between to account for each different piece of that pattern that the sine curve makes. To find out what the tick marks count by, you take the period and you divide by 4. So in this case, our period is pi, divide by 4. That means from tick mark to tick mark, we're adding pi over 4. So we would start here at pi over 2, we'd end at 3 pi over 2, and to find each of the pieces in between, we would add pi over 4 to the one before. Let's try out the one to the right. If it helps you, label A, B, and C. And again, take note that this B value is already factored out from the parentheses. The start you find by looking for your phase shift. Phase shift is the C value. It looks like plus pi over 4, but remember when you take it out of the equation, you take the opposite. So it's actually starting at negative pi over 4. To find the end, you take the phase shift, the starting point, and add the period, the length of time it takes to complete a full cycle. Go off to the side and find the period. B in this case is 1/2. 2 divided by 1/2. You can either do that in your calculator or you can do it by hand. When you divide, we're actually multiplying by the reciprocal. So we have 2 pi times, flip your bottom fraction over. We get 4 pi. So in this case, our endpoint is the phase shift, negative pi over 4, plus 4 pi, which gives us 15 pi over 4. If you're wondering how I did that, we have negative 1/4 plus 16/4, that's equal to 4 pi, or you could just put it in your calculator. Negative 1/4 plus 4, turn it back to a fraction. To find out what the tick marks count by, so if we were graphing this cosine curve, we'd be starting at negative pi over 4, and then we'd have 5 tick marks. To find what each one is counting by, you're going to take the period, divide by 4. Our period was 4 pi, divide it by 4, and we get pi. So each tick mark, we're adding on pi. Again, if this part's confusing down here, don't worry, we will be practicing that when we start graphing on the final page. In the final type of problems before we start graphing, we're going to try to write the equation of a sine function given some key vocabulary words, so given some pieces of the graph. It might be helpful off to the side to write your parent function of a sine graph. Y equals A times the sine of B times the quantity of x minus c plus d. So we can see where we're plugging in each thing. The amplitude obviously goes with A. So we know that this is our A value. We know that the period, or you should know that the period is associated with B. However, you'll remember that we have to do a little bit of work to find the period when we're looking at an equation. Remember the equation 2 pi over b gives you the period. Well, if the period is pi, we're going to set that 2 pi over b equal to pi. Our job is to solve for this b in the denominator so that we can put it back into the equation. In order to do that, we're going to put cross multiply. Stick that pi over 1 and cross multiply. b pi equals 2 pi. We want to solve for b, so we're going to divide by pi. And we get b equals, the pi's cancel out, 2. So we know our b value that we plug in there is going to be 2. And then last but not least, we know that the phase shift is associated with your c variable in the parent function. There is no d in this case, and that is a-okay. So let's go back to our equation and plug everything in. Y equals your amplitude, 2, times the sine of b. We found our b value to be 2, not pi. It's 2, times the quantity of x minus 1/2. Let's try it again off to the right. Oh, sorry, they're on the next page. If it helps you, again, write your base equation down beneath here. Now let's go through each of the pieces that we have. The amplitude is 3. That's the easiest one, A. We now know that the period is 3 pi. Remember, we set the period equal to the formula that gives us that period. It includes b. Stick that 3 pi over 1 and cross multiply. You should get b equals 2/3. It's okay that it's a fraction. The phase shift is your c value. And last but not least, we have the vertical shift, which of course goes with d. Try plugging those all in to your equation. We'd have y equals 3 times the sine of b, which we found to be 2/3, times the quantity of x minus, and notice that your phase shift is negative, so this is going to turn to plus 1/3, close your parentheses, minus 8. Pause the screen and try the one beneath this. After labeling your variables, you should have found each of these pieces to plug into your equation. A is 3, the b value is 2, the phase shift is -2, that's c, and d value is 3. Now, take those, plug them into your parent function. Y equals 3 times the sine of 2, outside the parentheses, x plus 2. Remember, you take this and plug it in as the opposite with the phase shift. Plus 3. All right, we've done all the prep work to practice looking at equations, finding different pieces of the graph. Now let's actually graph. So in these problems below here, we're given the equation at the top left, and then we're going to graph one complete period of the function on the x and y axis. Now, let's zoom in on number 1. On number 1, before we even begin, I want you to notice that this number that is in front of x, the coefficient in front of x, is still inside the parentheses. The first thing we're going to have to do is factor that out before we can find any of our other vocabulary words. So we have y equals, it's not going to affect the 3 out in front. We're just going to pull that 2 out in front of the parentheses. Now, when you factor out of 2, you're dividing everything, and I mean everything, inside that parentheses by 2. So we're dividing both of those pieces by 2. 2x divided by 2 just gives us x minus pi over 2. So now this is the equation that we'll use for the remainder of the problem. Rewind if you need to see how we factored that out again. It might be helpful in this next step to label your a, b, and c values so that you can easily find any transformations of the curve. Amplitude is, of course, given by a. It is 3. Remember, it's always positive. If it was negative, then we would flip the whole sine curve over. Period is given by 2 pi divided by b. So we have 2 pi over 2, which gives us pi. So that means from beginning to end of the sine curve is going to take pi units. Phase shift, look inside at C. It's minus pi over 2, so we're actually going to go right pi over 2. It's positive pi over 2. There is no vertical shift, so you don't have to put anything there. The starting point on the x-axis is given by your phase shift. So this is where our tick marks are going to start on our x-axis. Remember, to find the end point on the x-axis, we take C and add the period. So we're going to take pi over 2 and add pi. 1 whole plus a half gives us 1.5, or 3 pi over 2. So this is the end point on our x-axis. This is the beginning point on our x-axis. To find what we count by in between there, you take the period and divide by 4. The period is pi divided by 4. That means from tick mark to tick mark, we're going to be counting by 1/4 pi. The last thing that I left off here, I need to put it back, but y'all are going to write it instead, is the pattern. The pattern of the sine curve, remember, starts at the center, goes to the top, back to the center, down to the bottom, and back to the center. This pattern helps remind you of your shape, but it also reminds you that you need 5 different tick marks along the x-axis. Pause and rewatch if any of these different pieces, any of these different transformations along in this column were confusing, because now we're going to go along and we're going to label our x and y axis. Starting out with the vertical shift. Since there is none, that means our center line is 0. The amplitude, however, is 3. So that means we're going 3 above and 3 below the curve. Our x-axis, we're now going to label, it starts at pi over 2. It's going to end at 3 pi over 2. We need a total of 5 tick marks for each part of the pattern, so add in 3 more. We now have to label each of those tick marks. You'll remember over here that we're counting from tick mark to tick mark by 1/4. So take 1/2 and add a 1/4 to it. If you can't do that in your head, then you get your calculator out. 2/4 plus 1/4 is 3/4. 3/4 plus 1/4 is 4/4, which is pi. 4/4 plus 1/4 is 5/4. And 5/4 plus 1/4 is 6/4, which is 3 pi over 2. That's the hardest part that you have to do, is just figuring out what that x-axis is going to be labeled. Now, if it helps you, just as we're starting out, this is where the starting point is. This is where the ending point is. Now we can graph our points. Remember that the sine starts at the center, so go to your first tick mark, starting at the center. At the next tick mark for sine curve, you're going back to up to the top. Then back to the center, down to the bottom, back to the center. Connect your points. Remember that it is a gradual curve. It is not like V-shaped. It's a gradual curve, and it's a cyclical pattern, so it's going to continue on the left and right side. Before we go on to the next one, let's talk about the domain and the range. Domain is always the same, goes from forever to the left to forever to the right. The range goes down to -3, up to +3. That's what your y values can be. Pause and rewatch before we go on to the next one if anything was confusing there. Similar to our last one, you'll notice that the coefficient in front of x is still inside the parentheses. So let's take a second and factor this 3 out. Remember, when we factor the 3 out, we not only divide this term by 3, but the 1/2 by 3 as well. So we have y equals 2 times the cosine of 3 outside of x minus, and if you're confused about what 1/2 divided by 3 is, you can either multiply it out or you can use your calculator. So you should be left with pi over 6 inside. Now, this is the equation that we will use to find A, B, C, and D. Oops, not highlighter. A, B, C, and D. Let's now go through and fill in each of these pieces before we actually start graphing. Amplitude, period. Kind of a weird one here, 2/3 pi. Your phase shift, look inside the parentheses, take the opposite. So it is pi over 6, and I would make a note that you're going to the right, not to the left. Vertical shift. And to find the endpoint on the x-axis, remember it's the c plus the period. So this is the start on the x-axis. This is our end. So we take pi over 6, and we add 2 pi over 3. So we have 4/6 plus 1/6. You should get 5 pi over 6. If that was confusing, just add in your calculator. So this is our end point. This is our beginning point. You'll notice the difference between the start and the end is 4/6 pi, which is 2/3 pi, same as your period. And then to find what you're counting by on your x-axis, it's the period divided by 4. So your period is 2 pi over 3 divided by 4. Use your calculator to figure that out, or do 2 pi over 3 times 1 over 4. Get 2/12, which is pi over 6. Last thing I want you to include here before we actually start graphing is the pattern, so that you know the order that you're going to plot your points. It's a cosine graph. So remember, cosine starts at the top, back to center, down to bottom, center, top. We would flip it around if your amplitude was negative, or if the number out in front was negative. All right, let's start with our y-axis. Vertical shift is -1, so go down 1 unit, and let's make a new center line. So anytime in our pattern when it comes back to the center, this is the actual line it comes back to. The amplitude tells us how far to go above it. So we're going to go 2 above it, so the highest point is 1, the lowest point, -3. Now let's deal with our x-axis. We have pi over 6 to start, and we're ending over here at 5 pi over 6. We need 3 more tick marks in between, so add those in. And then you go back to what you're counting by. That's that last thing that we found down here. We're counting each tick mark by pi over 6. So we have 1/6 plus 1/6 is 2/6, which is just pi over 3. 2/6 plus a 6 is 3/6, 1/2. 3/6 plus a 6 is 4/6, so 2 pi over 3. And then 4/6 plus a 6 is 5/6, which is your endpoint. Again, if you wanted to do all that work in the calculator, you could. But we have our x-axis labeled, we have our y-axis labeled. Now we are ready to rock and roll. Go to your starting point. Remember, this is start, this is end. We're not starting on the y-axis. Go to your starting point and go up to your highest point. At pi over 3, the next tick mark, come back to the center. At pi over 2, go down to your lowest point. At 2 pi over 3, go back to your center, and then back to the top. You've got yourself a lovely cosine curve. Rewatch anything that might have been confusing for you, and then give the 3 problems on your homework a shot.